But hey guys, we got a lot to do today, so I'm going to go through some of this quick. We're looking at Cramer's rule again and 2x2 matrices this time. Keep in mind that Cramer's rule works in standard form. I'll ask that. Standard form, not slope-intercept form, not any other form. All right, so we use determinants to use Cramer's rule, and a determinant is a value. The determinant of a matrix is a value. It's not a matrix. Keep in mind that determinants are set off by straight lines. This is not indicating a determinant. That's just indicating a matrix. Let's keep going. All right, so there's kind of a formula for the determinant, and we're going to develop it kind of quickly, but it's just this diagonal, the product of this diagonal minus the product of that diagonal. Okay, so see if you can do, this is problem number 1. All right, at Socrative, when I refer to problem number 1, this is what I mean. May not be the actual first problem at Socrative, but when I refer to problem number 1. All right, the discriminant is -4. It's just this product, -10, minus this product, -6 is -4. Let's play this game for about 5 problems, and I'll ask about these. Pause the video. Discriminant's -11. So that's -3 minus 8, -11. Again, pause the video. Discriminant is 28. That product is 10 minus that product is -18. The discriminant, 28. Pause the video. Discriminant is -20. That's 0 minus 20 is -20. I'm not sure how many we have of these, but let's do them. Pause. Discriminant is -12. So that's -36 minus -24, which is -12. Okay, so if we were to take a system of equations that's in general form or in standard form, but what I mean is that the coefficients are just letters, not numbers, and we were to use the elimination method, okay, and eliminate the x's, then we would multiply that by c and this equation by -a. All right, and then what would happen is that's what you would get when you multiplied. If you needed to pause the video and look at how I came up with that, then by all means do that. And then we would get this. You know, when you subtract those two terms, they're unlike terms, so you would write it like that. And then, you know, what would we do at this point? Well, we would factor out a y. But y is the GCF. And keep in mind, we're trying to solve for y. And then we divide both sides by, what now? Divide both sides by BC minus AD. Okay, this cancels that. And then if we take this result right here and compare it to the original equations, then determinants pop out. So I do need to multiply the top and bottom by -1 to create this. And you can see that if you pause the video and think about it. If you had a problem with it, come and ask me about it. And then if we compared them, if we were to compare this original matrix to, original system of equations and tried to build matrices that matched that, you know, AD minus BC, well, it's 1-to-1. The A is the first entry, the C is the entry here, the B is the entry there, and the D is the entry there. And that is the denominator of y when you try to solve it. And you can play the same game for the numerator. Let's do that quickly. Yeah, this is the numerator that if you tried to pick out, you know, it's AF minus CE. So A and F have to be on that diagonal, and C and E have to be on this diagonal. Then, and looked at and compared it to the system of equations, well, the A is here, the C is there, and the E and F are used in these positions. And so we want to see that pattern quickly, okay? Right now it's not quickly. So we'll practice on that, and if you want to pause and read, you can. So if X is always going to be like this, if we were solving a system for X, the denominator is that. And for Y too, or also. And then the numerators are what has to be, is what's different. And so for X, the E and F go here, and for Y, the E and F go there. All right, let's practice that and put this into practice a few times, and then we'll do an assignment over it. All right, so if we were going to set that up for Y in Cramer's rule, that right there is your denominator. So let's look at it. What I like to think of it is that's the we've already talked about the denominator, but repeat it to the top. Of course, that value would be 1 because anything divided by itself is 1. And if you're solving for Y, you take out the Y coefficients. Let's see if I can get this to work. Yay. And then you put that into the constants into the Y column. And then you would do the same thing for X. All right. That's what I just did. If you want to look at it, stop and look at it. All right, so if we were to do this for X, let's just do this right here, that X is equal to, that's the denominator. Let me do it like this. Too late. That's the denominator, 1, 5, 3, 4, and then just recopy it to the top. And since we're solving this for X, then we would take out these values and put in its place the constants, which is -1, -7. And that's X. And then you would just evaluate each determinant top and bottom. All right, that's just a recap of what we just did. Okay, so let's use this kind of quickly. Let's use this to determine if lines are parallel. Here I go, parallel, overlap, or intersect. If lines intersect like this, there's only one solution. It's the point where they intersect. If lines overlap like that, there's an infinite number of solutions. And if lines are parallel, there's no solution because they don't hit. And we can use the Cramer's rule to quickly point that out. Let's look at this slide. Okay, we can see that the determinant of the denominator is not going to be 0. You know, it would be 15 minus 4 is 11. If we know that the denominator is not 0, then we know that we have a system of equations where the lines are just going to overlap at one point, one way or another. And that's all we're trying to figure out. So if we had a problem like, that's what I just said. Let's look at this slide. A problem like this. Let me take out some of this stuff and just redo it. It's kind of, let's just look at it like this. If we did that determinant on bottom, you know, it would be 2, 4, 3, 6, and we can easily see that it's 12 minus 12 is 0. So we have a problem. We can't divide by 0. And then if we were to set up, you know, I've got this problem set up for the Y, set up to do Y, because I'm just kind of taking these out and going 2 times 5 is -10, or let's just build that. So it'd be 2, 4, -1, -5. And so the top would be -10 minus -4, which is -6. So if the top is non-zero, then what we have is parallel lines. They don't overlap. There's no solution. And if the top were 0, I'm just going to jump to that and say, if the top were 0, then what that would happen is these lines would overlap and we would have an infinite number of solutions. And you can let's do some problems because it's getting long in the tooth here. All right. You might want to pause the video and see if you can answer that. But we can see that this determinant would be 6 minus 3 is 3 for the Y setup. And then the answer is one solution. If the denominator is non-zero, it's one solution. You don't have to do any more. So you kind of want to do the denominator first. Okay. So if we did this, we would get 12 minus 12 is 0. And then if we were to do this is actually the Y setup, 40 minus 40 is 0. We get 0 over 0, which is infinitely many solutions. So you can do y just by looking at it and not actually build the matrices. It's something you can do really quick. All right, let's do this one. So this would be 36 minus 36 is 0. Negative 64 minus negative 60 is negative 4. Hope I did that right. But anyway, so that makes it not that. Then when you have 0 on the bottom and then you have a non-zero on top, it's no solution. So what that means is that the lines are parallel. Let's see what we have left here. All right, that was the last problem. You can kind of see that, and there'll be some problems like that. This one's getting kind of long, so let's end it. Let's do our cameo appearance real quick, though. The cameo today is Mr. Sulu from Star Trek. Man, that makes me want to go watch Star Trek 4. I believe that's from Star Trek 4. All right, guys, I'll see y'all later.